Let me see. Okay, the number is okay at least. The number has increased a bit. Let me go down, 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 down. Either Kantari, are you there?
Yes, teacher.
How are you?
Yeah.
Either I am going to share a document and you are going to guide us through this number. Is that okay? Either.
Yes, teacher.
Okay. Nora has a question.
Yes, I have a question.
Yes, please.
Before we continue, I first wanted to ask a few questions from the work we did yesterday.
Yesterday?
Yes. Okay, our last physics lesson.
Yeah.
When we're looking at frictional force.
Yes.
So when we're finding the work done by the frictional force, I have two questions. The first one, when we're finding the work done by the frictional force, do we multiply times the distance moved by the force that's moving the load, or the friction force also has its own distance?
Okay. The friction force, the distance moved by the friction force is the same distance moved by the body that is moving, by the moving body. So if the body has moved a distance of 30 meters, the friction force has also moved through 30 meters.
Oh, and my second question was on a number we did yesterday on the inclined plane.
Yesterday, I don't remember teaching you.
Okay, not yesterday, but like the last lesson.
Yes.
Yes, the last lesson. So we did the inclined plane, and then he wanted us to find the frictional force, and I didn't necessarily understand, because we said that work done against friction was the work done through the inclined plane minus the work done vertically. I didn't understand that, because isn't the work done against friction the work moved by like the force that's moving the load, since the force that moves the load is against friction, so it's work, isn't it the work that's against friction?
I don't think you are alone in that problem. I think we were many people. So since we are going to take our time and try to understand what we are doing. Is that okay? Do you see the blackboard?
Yes.
Okay, can you tell me what our force was?
The force was 130 newtons.
This force was acting in that direction, 130 newtons. Then length.
I can't see
this?
Yeah, we cannot see properly.
I can't see the parts of the blackboard you're writing on right now.
How long was this?
14 meters.
14 meters. That is the length. What was this height?
5 meters.
H, and it was 5 meters. Is that okay?
Yes.
So, what was the first question? Okay, what was this weight? Give me this weight, the weight of the load.
30 kilograms.
The mass was 30 kilograms.
It was a mass.
Yes.
30 kilograms. Is that okay? So let us find this weight here. Our weight here. Which we shall call W is given by what formula?
Mass times
Gravity, mass times gravity.
Okay. So this is 30 times 10, giving us
300.
300 newtons. So our purpose of the inclined plane, remember the purpose of the inclined plane, it is a machine which is supposed to simplify work. So we are supposed to lift this load and until it reaches that height. And that height represents that the load has moved through a vertical height of how many meters?
5 meters.
Making it easier as vis-a-vis someone carrying it from that point.
Okay, so it makes it easier because instead of lifting it directly, you are simply dragging it along a plane, and that work is easier than lifting it directly because lifting it directly is not as easy. So we use an inclined plane to ease that job. Is that okay?
Yes.
So what we call the useful work is basically the purpose. The purpose why you use an inclined plane is to lift a load from this height to that height. So we call that useful work. Okay, and this useful work was given another name. What was that name?
The work input.
Work output.
It was called work output. That is what we refer to as the work output. That is what the intention was. And we say that this work output is given as a product of what?
A vertical distance.
It is called in a load
Times
the
load distance.
distance. Okay, moved by load. Is that okay? So in our case, our load is this weight. What is this weight?
300 newtons.
Newtons.
Am I still with people?
300 newtons. 300 newtons.
Okay, it is 300 newtons. So what is the distance moved by the load?
14 meters.
5 meters.
5 meters.
It is 5 meters. This load, listen, this load here is something we have not verified very well. You know this is mass, but this is the load. The weight of the load. Okay, we are calling it the load, but it's supposed to be the weight of the load. And it is given by the weight, which is equal to mg, which we have verified is 300 meters. Is that okay? Now look carefully. Exactly. That's what I want to explain.
Supposing you had the load at this point.
Girls, you pay better attention.
The load was here.
Let us look at the direction of the load. What is the direction of the load?
North.
You see that it is there.
Yeah.
The load always acts in the direction of gravity, isn't it?
Yes.
So it is acting vertically, or it is acting in that axis, which is vertical axis, isn't it?
Yes.
Yes.
So when you are lifting a load, you look at the distance that is in the same direction. And which distance is that?
5 meters.
So because forces have direction, the load does not move along this direction. The force that moves along this direction is called altogether. It is the one that is acting in that direction. I hope you get the idea, girls.
Yes.
Am I making sense?
Yes.
Yes.
Okay, so the load moves vertically. This is the force, that is the direction of that force. And the distance, that distance is this one. That's that distance. So the effort is going to be moving along that direction. Is that okay?
Yes.
Yes.
I hope you see the different colors. So this will be the distance moved. This will be the distance moved by the effort. This will be the distance moved by the load. Okay, I should actually put it in the same color as distance moved by the load. Where is it? Pick a small piece of chalk.
Which one?
Has disappeared, the big one. Because the directions have to be very clear. Let me use the result to this one. So this is our DL. And this is our L. So this direction is here. I hope I'm very distinct. So that is what we have. Easy. And whenever you are doing that, if you have different color, identify the two distances. I think it makes it clearer. That's why I said that this distance here is multiplied now by which distance? The distance is the same direction. Is it 5 what? 5 meters. Is that clear?
Yes. Yes.
So what do we get as the work? The useful work, which you call the useful work output.
1,500.
1,500.
So that is 1,000. So I'll call this work out, which is equal to 1,500 newtons. Is that clear? Okay, joules. Is joules, girls, is joules. Okay. What was our next question? I'm repeating this question because I understand that several people did not understand it in actual sense. So what was the next part of the question?
And the work done by lifting the box vertically upwards.
That's the work done.
I think
And the
that's
work
the,
done by force of 130 newtons.
by the force of the what?
130 Newton.
So what did we call that work? That's work done by effort. Is that okay? So that's
Yes.
our work input. So our work input is actually the effort times the distance moved by effort. And those two must have the same direction. Is that okay?
Yes.
Those two must have the same direction. So our effort is 130 newtons. So it is moving along which direction? The plane, isn't it?
Yes.
Yes.
So what is that distance?
14 meters.
14 meters. And what was our answer?
1,820 joules.
1,820 joules. Is that okay?
Yes.
Now we discover that the work output and the work input have a difference, isn't it?
Yes.
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 So we say that from the principle of conservation of energy, can somebody remember that principle?
Energy can neither be created or destroyed, but only changes from one form to another.
So very good. I think that is Jovi. I think she knows that principle. She has an idea of that principle. So how do we put it in this way, mathematically? The work input, that is the work you put into the machine, will be equal to the work the machine does for you. That is useful. Work output.
Times the distance.
Say work done against friction. Is that okay? That's what creates the difference. So, what is our input?
1,820.
Very good. What is our output?
1,500.
Very good. What is the remainder?
320 joules.
F.
Not yet. Work done
Against friction.
Against friction.
Is that okay? That's
No.
the main. So conclude. Work
Work done against friction is equal to
against
work input minus work output.
very good. Giving us
1,820 minus 1,500.
120
joules.
320
Joules.
Is that okay?
No.
Yes.
No.
He's
No.
saying no.
They
No,
know. I don't know why it is not okay.
Let her tell us.
It's not okay from after we form, like from the work output is equals to work. The work input is equals to work output plus work done against friction. That's why it's not okay.
It
Okay.
is. Okay. If we subtract from here, 18 minus 15, if you take this one,
Let's start from here.
No, that's okay, but like
Let's start from here. Do you see this value?
I can't
We
see
can't
up.
see it.
Do you see this value?
You
Yes.
can now see.
What does it represent?
It represents the work output.
And what are we saying the work output is?
The whole the work output is the whole point of like the purpose.
It is a useful work. Okay. Now, for us to get the work out of any machine, that's the work that is going to give us, we have to do some work because work is neither created nor destroyed. The work must be having some source. Are we together? So that source is usually provided by the effort and then the distance. For example, if you are riding a bicycle, I'm using a bicycle, you have to put in an effort to pedal, isn't it?
Yes.
So the
Yes, teacher.
pedaling provides you the effort. Is that okay?
Yes.
Then the distance moved by that effort times the effort will give you what we call the work input. I think, so how much work have you put in the machine for it to give you this 1,500? Is that okay?
Yes.
So what do we discover between the two works, the work input and the work output?
The work input is the effort I put in, and the work output is like the work that comes after my effort.
And what have you discovered between those two?
When you look at the values,
what happens? Are they the same?
No,
They are not the same. Which is bigger?
the work input.
The work input is bigger. For most machines, the work input must be bigger than the output. And we want to give you the following reasons. Because remember, while you are doing that work, there are some systems of the machine that for example, if you pedal, you could hear noise, you could get friction and so on. So your work input must also be able to overcome the work done against those other sources of energy, like friction and sound. That's why always the work input is bigger than the output, because we say that the output is the useful one, but there are some wastages. I hope you get the point. And those wastages are mostly due to friction. So the difference between the work input and the work output is usually the work done against that friction.
So the work done against friction is basically the work friction is also doing.
Yes.
It is like the work done to overcome the frictional forces. In other words,
the work done by the friction is the work actually the friction is doing. That is it.
So the work done against friction is the same as work done by friction.
Yes.
So the work input, the work you put in, if I could put it in that way, has to overcome friction and at the same time do the work you want it to do. In this case, it has to lift that load through a height of 5 meters, but as it is dragging it along the plane, it has to overcome frictional forces.
There's friction force between this body and that surface.
Yes. So the work you put in has to take the load up, but
also overcome the friction between the surfaces. Remember that friction opposes the motion.
Yes, so if I don't put in enough work input, the frictional forces will be too much and I won't be able to.
And you'll not be able to lift.
Let us do the following. You see this piece of wood here?
Yes.
Do you see this, whatever? I want to put it here. I think let's get something here. So suppose I'm pushing this load. Is it moving?
No.
Suppose I increase the force. What happens?
It starts moving.
Now you do that at home. Get a stool or whatever and start pushing, applying your force slightly. All together. If you don't apply enough force, the body you want to push will not move. I think you have experienced that.
Yes.
So that is friction trying to resist the motion you are creating.
So in that case, it would mean that the work you've put in
is not sufficient.
Is even less than the frictional force. It cannot even object. The work you put, and then enable the body to move.
Does that make sense?
Yes.
Yes.
So are we okay now? Have we understood that problem, people?
Yes.
I think I've explained it better the other time we were in a hurry. Now, the question, did this question require the friction?
What was the other part of the question?
Because in this case, I will also ask you to find the friction. How would you find the friction?
We have to first get the work done against friction, and then we do work done against friction is equals to friction force
times distance.
Exactly. Wow. What distance would it be now?
14 meters.
14 meters.
Very good.
Now you've understood.
The distance moved by the effort is the same distance because this body has moved along that surface. So the friction is also along that surface. So that is it, but it is acting in the opposite direction. This is the friction force, usually. So this is friction. Are you seeing that arrow which I'm drawing? Guys, are you seeing that arrow which I'm drawing?
Yes.
That arrow, if the effort is dragging the body upwards, the moment you see that your motion is in that direction, then friction will be always in the opposite direction. Is that okay?
Yes.
Why
So
is
I mean,
the opposite direction of the motion?
Because friction opposes motion.
So we are looking for the work done against friction. Work done against friction will be equal to the friction times the distance moved by the effort or the distance moved by the load. The actual distance moved by effort. Distance moved by effort. So this will be equal to 320. The friction we don't know. I'll label friction with that simple R. Then I'll know this distance is 14. So I'll divide by 14 both sides. And what does our friction become?
22.9.
22 point something.
0.9.
0.9.
Newton.
Is it 0.9?
To at least 3 decimal places.
How many decimal places do you have?
Not different. No. Unless I use that phone.
22.857.
She rounded off to one decimal place.
0.8
57.
newtons. Friction is measured, it is a force, so it is measured in newtons. Clear?
Yes.
So please don't round off to one decimal place. Give
Okay.
3 decimal place.
So I hope that question is clear, girls.
Probably they add the
Yes.
frictional force.
Was this question part of it? Part of the question to find the friction force?
Yes.
Teacher.
Yes, teacher. Let's see.
Teacher, so does the friction also move downwards but the same distance as the load, or we just use the distance that the load has moved to calculate the work done by the friction?
The friction will always move the same distance as the effort.
So it moves the same distance as the effort, but in its own direction downward.
In the
Opposite.
opposite direction. In the
Not its own direction,
in the
opposite direction.
The motion, its direction will be opposite the motion of the body you are dragging. So if you are dragging the body upwards, the friction will move downwards because it is opposing that motion.
If the motion was moving downwards,
If
then
the motion
friction would
down, friction goes up, moves in the opposite direction. Because
So if you want-
by definition, what is friction?
Friction is the force that opposes motion.
So if it opposes motion, the moment you see motion taking place in one direction, then definitely friction will be opposing it, so it will be in the opposite direction.
So, okay, so friction will move the same distance but in the opposite direction.
Exactly.
Okay, thank you.
You are welcome. Okay, that was that question. I hope it has been explained better. And I hope others have understood, those who are quiet. I know there are always some very quiet girls who are now WhatsApping. You know, you are supposed to be your own prefect now. So if there is nobody to look after you, mom thinks you are busy. Kumbe for you WhatsApping. Okay, let's move on. We have another question. We are left with another question here. That was work output. That was up there. But we had moved some questions here. I hope girls remember that we had done question 1 and question 2, and we are moving to question 3. According to what I've displayed. Is that okay?
Yes.
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 Yes. Okay. Now, I wanted Heather to do something for me. Heather, are you still there? I still remember.
Yes.
Yes, Bambi. Okay, great for me. Question 3.
A pump delivers water at a rate of 1 liter per meter wheel. Find the power of the pump.
Rate of
A pump delivers water at a rate of 1 liter per hour to a tank 20 meters above a well.
what?
20 meters.
20 meters above a well.
Find the power of the pump.
So we are supposed to find power. Okay. Okay, girls, that is our question. Now let us look at this question and understand it properly. Our rate is given in terms of what is that unit?
Liters.
Is liters, and liters is a measure of what quantity?
Kilogram
Yeah?
For what?
of liquid.
It's a measure of what?
What is measured in liters?
Liquid.
Nenda wanyama na mwe physics.
Capacity or a better one?
Whatever.
Volume.
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 Good.
So this is volume. What is measured in hours?
Time.
Time. That is our rate. Is that okay? So our rate is 1 liter over the time taken, which is the 1 hour. Okay, we need to convert this and understand what it means. Out together?
Yes.
1 liter, and then we are also going to look at power. The height is in the meters. That okay? Distance will be in meters. So what is the weight of 1 liter?
1 kilogram.
A weight of 1 liter. Tell us how you get that. Weight is given by
You said
Mass
one.
times
Mass
gravitational
times
acceleration.
gravity.
So mass is given by
What is the mass of 1 liter?
1
1 kilogram.
Oh, let us work slowly. What is the equation for mass in terms of volume?
1,000 cubic feet.
No, rearrange the formula
Mass is
for
given
by volume times
volume times the
density.
Density.
so we have volume times the density times the gravitational acceleration. That is the weight of 1 liter. So what is this volume? How many liters? This is 1 liter. So 1 liter is equal to what? How many cc's? Actually, we should convert this to cubic meters. How many?
1,000 meters.
This is the same as 1,000 cubic centimeters. But what is it in the cubic meters?
1 cubic meter.
Banange nedda mulala bidde math mu. This is 1,000 cc's.
100
So how many meters cubed?
0.1
1 million cubic meters.
So I'm going to divide that 1,000 by 1 million. Are we okay?
Yes.
So this will be 1,000 divided by 1 million. Okay, I'll explain that later. So times what is the density of water?
1 kilogram.
1,000 kilograms per cubic
What
meter.
is G?
So where is the 1
The
million?
gravitational acceleration.
I'm going to explain that. What is G?
Acceleration due to gravity.
That's what I have. Now let me go slightly back here and explain why I'm dividing by. 1 meter has 100 centimeters. Is that okay?
Yes.
So 1 meter times 1 meter times 1 meter is the same as 100 centimeters times 100 centimeters times 100 centimeters. Is that okay?
Yes.
That's okay?
Yes.
What do I get? 1 meter cubed is the same as
1 million.
1 million centimeters.
160.
Now that implies that 1 over 1 million is the same as 1 centimeter cubed. Is that okay?
Yes.
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 When I divide both sides by 1 million, what do I have?
1 meter cube.
Centimeters cubed will be the same as. I think you have seen where the 1 million comes from.
No, teacher, we still don't understand.
I'll say the 1 meter cube times 1 meter cube times 1 meter cube is the same as
100
100
centimeters.
100 centimeters.
1 meter is the same as 100 centimeters times 100 centimeters times 100 centimeters. This gives me 1 meter cube. This gives me 1 million centimeters cube. Is that clear?
Yes.
Yes.
Now I've said if I want to convert 1 centimeter, I divide everything by 1 million.
Okay.
That is okay.
Yes.
Now, if I multiply both sides by 1 million, what do I get?
0.001.
Is that okay? So 100 centimeters cubed is the same as 1 million, I mean 1,000 divided by 1 million meters cubed. Is that clear now?
Yes.
So that is why I got the 1,000 cc's. I multiplied, I divided them by 1 million to convert them to meters cubed. I multiplied by the density of water, which is 1,000. I multiplied by the gravitational acceleration. So what is the weight that we get? Remember, Kachimu was telling me 1 meter. Me, I was disagreeing with that. 1, 2, 3, 1, 2, 3. 3, 3, 3, 3. So what's the weight?
10
Newtons.
10 newtons.
10 newtons. Okay, 10 newtons is equivalent to 1 kilogram. That's the truth in terms of mass, but we get 10 newtons as the weight. I hope we are together.
Yes.
Yes.
So that is our weight. Remember, we are looking for power. Girls, is that okay?
Yes.
A question, the work done by the pump. Now let us go to the power. What is the power? Who remembers power?
Power is work done divided by
Now, what done is the product of
Force times distance.
In this case, what is our force?
10 newtons.
The weight of the water, isn't it? And what's the distance?
20 meters.
20 meters.
80. I'm substituting first symbols.
yes.
And then what is the time? The time. Is that okay?
Yes.
Now let us substitute in this formula. Our weight is it?
10 Newtons.
10.
Our height is it?
20.
20
20
meters.
meters. Our time is it?
3,000.
3,600 seconds.
Hey, people know what to do. So these are joules, these are seconds. So we handle that and that. So okay.
Yeah.
Divide by 36.
1 out of
1 out of 8.
18.
0.0551.
1 out of
18. And these are what, isn't it?
Yes.
So what is 0.556
556 watts.
0.5.
Recurring.
5, so we can say 6, and these are what? Capital W.
556.
There's already a 0.
0.5, okay.
No, it is.
It's okay, whatever she wants, but you can approximate to 4 decimal places. So this is the rate of working. Is it clear, girls?
Yes, teacher.
Yes, teacher.
Any questions?
Okay.
Anyone with a question? Karen?
Excuse me, teacher. When we are going to the part of the turning the weight for mg, that side. Yeah. You said weight of a liter is equal to mg, but m is equal to v is equal to, okay, what does that mean? The other working of m is equal to v and density.
Volume times density.
Density.
Rho stands for density.
Remember the formula, density is mass over volume.
Volume times density. So the letter rho is what is used for density.
But are you getting the mass or you're getting the weight?
Now, Karen, depending on what was given in the question, what was given? We were given the rate, and they gave it as 1 liter per hour. Okay? So that means we have, and the liter is a unit volume. Can we mute, kindly mute, so that we answer that question? The data that was given, the information that was given was giving a rate, the rate at which the pump was working. And they said it pumps a liter per hour. And the liter is a unit of volume. That is why he changed here from liter to volume per hour. But now, remember in our working, when you're finding power, we shall need the weight or the force times distance. So how do we get the weight from this information that we have? That is why he brought it here. That weight is mg, but we don't have the mass. We don't have the mass, but we can get it from the volume, the information we've been given. That is why, now, instead of mass, he said volume times density. It comes from that formula, density being equal to mass over volume. When you rearrange and make mass the subject, then you get mass is volume times density. Then this G is what is here. So now this one, now the working here is trying to change the volume. Remember the volume was in centimeters cubed. We had to change it to meters cubed so that eventually we can multiply by the density of water. So that is what was doing here. 1 meter is 100 centimeters. Therefore, 1 meter cubed is 100 centimeters cubed. And then he made, therefore, 1 centimeter cubed is equal to this. Now, how about the 100 that we, I mean the 1,000 that we have in our question here? Remember our volume here is the 1,000. That is why we did it here. How about the 1,000? And it came to, what did it come?
1,000 divided by a
1,000. Okay, he picked it the way it is directly here. For 1,000, it is 1,000 divided by a million. So we put it in this formula here. The volume, 1,000 divided by a million times the density of water. Now, since the volume is in meters cubed, the density, we should use the density of water in kilograms per meter cubed, which is 1,000. That is why this is 1,000 here. And then this 10 is the acceleration due to gravity. So when you work it out, it simplifies to 10 newtons. Karen, are you okay? Karen, I think it is Karen or Karen?
Yes.
Imani,
Yes.
Is that okay now? Okay.
Okay.
Another question? We might even stop on that one. Any other question? Okay, looks like there's no other question.
Okay.
Let's look at question 4.
Question 4. Is it a PDF?
You can't.
Right. It's like that.
Okay, so we move on to question 4.
I'm looking for Where is Sarah? Let me say, Sarah, Talita, are you here?
Yes, teacher.
Number 4, read.
Read number 4.
We have 5 minutes.
A man of mass, 75 kilograms.
The mass is 75 kilograms.
Walks up 12 steps, each 20 centimeters high in 5 seconds.
So
12
steps.
Each 20 centimeters.
So height of 1 step. H is what?
20 centimeters.
20
20
centimeters.
centimeters. 20 centimeters.
Yes.
In 5 seconds.
Time.
It's 5 seconds.
T is 5 seconds.
Find the power he developed.
Power he develops. So girls, 8, 9, 10, 11, 12. 1, 2, 10, 11, 12. 12 steps here. This man starts here. Okay. So he's trying to climb steps. Is that okay?
Yes, teacher.
Is that okay, guys? So what is the total height he's going to climb? What is the total height?
20 times.
20
Times.
times
12.
centimeters. Very good. So this height reduces to
240.
240.
Which reduces to 2.4. Agree?
2.4, yes.
Okay. Now this man has a mass. His mass is how many kilograms?
75.
75 kilograms.
25.
Change this to weight, which is equal to mg, which is equal to 75.
Time.
What is our weight?
700.
700 banana. 50. Is that okay?
Yes.
Now,
Someone will
do
interfere.
you see the direction of the weight? What is the direction of the weight? It is vertical, isn't it?
Yes.
Now, this weight is being lifted through how many meters?
2.4 meters.
So what is the work done?
750 meters.
750.
Then is
2.4.
the weight of the
Weight of the
metal.
We shall get mg, capital mg, divided
750.
by the time. Are we okay?
Yes.
Yes,
Are we
teacher.
see how we calculate power?
Yes.
So what is mg?
750.
750. What is our height?
2.4.
2.4. What is
Divide by
our
5.
time?
Yes.
5
5
seconds.
seconds.
5. What is our unit?
360.
Is what?
360.
I hope you are correct.
Yes, teacher.
We are.
We are
And
correct.
these are watts. Thank you very much. Now, this is your assignment. Get a friend go and climb the stairs and somebody times you, and then you will see the personal work. Those of you who are fitness, you can measure your power.
Stairs.
You have what?
Don't we have 3 steps?
You borrow something from somebody's building. They are not. You borrow some stairs. Okay, you'll come back here. There are several stairs around your classroom, but the best place is maybe the swimming pool.
Swimming pool.
In Gaya's high school, there's a swimming pool which has a pavilion, which has steps there. You can run those steps up.
Yeah, so they made
So you measure that height, you measure the number of steps, you get the vertical height through which you are reaching your height. You measure your mass or your weight. I hope Coach Dam has a weight, and then you can measure your personal power. Is that okay?
Yes, teacher. Thank you.
So briefly, those are the notes that follow. How to measure what? An experiment to measure what? One's own what?
One's own power output.
Okay. I think we have a minute. We have a minute. Read that and we call it a day.
Working in groups of twos. One time.
Who is reading?
Shona.
Okay, Shona. Shona is very fast. I like her.
Walking in groups of twos, one times the other in turns, as one runs up a flight of stairs as fast as he or she can. The time T taken is recorded. The weight of the person is measured using a weighing machine. The power is determined as follows. The height X of one step of the staircase is measured. The number of steps is counted and noted as N. Height moved up, H, is equal to number of steps N times height of one step times, X.
Then?
Okay. Work done is equal to force times distance, which is F times H, and F is the weight of the person, which is equal to weight times height. The time taken to move a height H is equal to T. And should I continue?
Yes, please. You are completing that experiment.
Oh, okay. P is equal to work done against gravity divided by time taken. And P is equal to W times H divided by T, but H is equal to N times X. So could I ask what N stands for?
You read it up there.
Now we will what is N?
Sorry, number of steps.
And what is X?
X is the height
of steps
of each. The height of one step.
So in our case, our N stands for 12, our H stands for 20 centimeters. Is that okay?
Yes.
Our X, yes.
Note, every quantity must be in its SI unit.
So so they are telling you that whenever you have calculated that, convert to the proper unit, which is the what? Which is the what? What is the unit of power?
Watts.
Exactly. Whenever they talk about what, you simply say what. When the teacher asks you what is the power of what is the unit of power, you say what. The opening statement is the unit. But the spellings are different. Okay?
Yes.
Teacher, you have to always use meters.
Yes.
SI unit.
The SI unit, whenever you are converting SI units, so you must convert to the proper SI unit for every unit or quantity that you have used.
There's someone who had a question. Can you
Is that okay?
pose your question now? Before Shona read, someone was asking a question.
So it was me. No, maybe us.
Okay. Closing prayer.
we are done for the day.
Closing
So
prayer.
we can close the day with a prayer. Thank you so much, girls. Have a lovely day.
Rina, pray.
Teacher, before she prays, please remember to put the recording on Google Classroom because my signal hasn't been stable and there are some points I missed.
Yes, yes, we shall send them. Let's wrap up with a closing prayer.
Rina.
Humble ourselves for closing prayer. Heavenly Father, thank you for the gift of life. Thank you for enabling us to finish the lesson without any network interruptions. And dear Lord, I pray that you help us continue living the day to day. In Jesus' name, I pray. Amen.
Amen.
Okay.